A logarithm number consists of two parts. There is the first part before the decimal point, which we call the characteristic. So we have characteristic, then a decimal point, then a mantissa. So the characteristic is the number that you write before the decimal point in a logarithm number, while the mantissa is the number we write after the decimal point. This characteristic is obtained from the power of 10 after we have written the number in standard form, while the mantissa is the one we read from the tables. The characteristic can be a positive number, a negative number, or even zero. A mantissa can never be negative, it's always a positive number. So we have these examples to work, and before the examples we need to have the steps that we use in getting a logarithm of a number. These are the steps. We express the number in standard form, take the power of 10 as the characteristic, and then we take the value written in the A section and we read it from the table to get the mantissa. So here are the examples. Starting with the first one, 3.78. When we write 3.78 in standard form, that number will be 3.78 times 10 raised to power 0. Now this power of 10, which is 0, will be the characteristic of the logarithm. So the logarithm will be 0 point. Then to get the mantissa, we read this number from the 4-figure mathematical tables. So we have an extract here for logarithm. We are looking for 3.78. We look for 3.7 in this first column. Then the third digit is looked for between here and here, and the fourth digit is looked for between here and here. So we are looking for 3.7 here. 3.7 is here. And then we go to column 8. So this column 0, column 1, 2, 3, 4, 5, 6, 7, 8. So the number is 0.5775. So we shall write it to be after the decimal point as indicated here. And therefore the logarithm of 3.78 is 0.5775. The second number is 420.6. When we write it in standard form, we need to move this decimal from here to here. So the new number after moving the decimal will be 4.206, then times 10 raised to power 2. Why 2? Because the decimal was here and we have moved it to this position, and in so doing we have skipped 2 digits, so we have power 2. This power 2 here becomes the characteristic of this logarithm. So the logarithm for this number will be 2 point something. Then for us to get the number right after the decimal point, in other words the mantissa, we need to get the mantissa from the logarithm table by looking for this number 4.206. So let's look for 4.2 here. 4.2 is here. Then 0 column is this one. So 4.20 gives us 0.6232. We write it up there. And then we add. We normally add when we have the fourth digit that we are looking for in the logarithm table. So we have this 6, which we have to look for here. So we have the 6 is this one. We move downward so that we get to the position where it corresponds to 4.2. 4.2 is here. Then this is column 1, 2, 3, 4, 5, 6. So the number is 6. So we shall add it here. We write this 6 to the extreme right in a way that it corresponds to the last digit of the number that we had written. So we have the 6 here. The rest of the spaces here are replaced, or they are filled with zeros as indicated. So when we add that, this gives us 8, 3, 2, 6, 2. That means the number is 2.6238. The third number is this one, 0.1675. In order for us to write it in standard form, we have to move this decimal from here to here. So the new number will be 1.675 times 10 raised to power -1. Why -1? Because we have skipped one digit when we moved the decimal from here to the new position. So it will be -1 because the movement is in the right direction. In short, if a number starts with 0 point, then the power of 10 must have a negative sign. So this will be the characteristic for the logarithm. The characteristic will be -1. But because it's only the characteristic that can be negative, the mantissa can never be negative. We write this negative on top of 1. So it will be indicated like that. And we read it as bar 1, bar 1 point. So when you see a dash on top of a number, it means bar 1, bar of that number. In this case, it's bar 1. And then we look for 1.675 from the table to get the mantissa. 1.6 is here. Column 7 is this one. 1.6 column 7 is this one. So the number is 0.2227. We write it up here. Then we add. So we look for 5 in this third section. Column 1, 2, 3, 4, 5. This is column 5, where it corresponds to 6. We have it as 13. 1.6 is here, and then 5 is here. So the value is 13. We also write it to the extreme right in a way that it corresponds to the last 2 digits of the number we had read before. So we had read 0.2227. We have now read 13. So we write 13 the extreme right like that, and replace this, or we replace these ones with zeros as I've indicated. And when you add, you get this gives you 0, carry 1, plus that gives you 3, that's 4, then 2, 2, then by 1. So that is by 1.2240. The last one is this one. So for us to write in standard form, we have to move this decimal from here to here. So the new number will be 5.294 times 10 raised to power. How many numbers, how many digits have we skipped? We have skipped 1, 2, 3, 4 digits from where the decimal was up to where we have put it. So it will be times 10 raised to power -4. As I said before, the shortcut is if the number you are writing in standard form starts with 0 point, then the power must have a negative sign. So that means the characteristic will be -4, which is written as bar 4. So we have bar 4, and then we read the mantissa using 5294, 5294, 5294. Look for 52. 52 is here. 9, this column 9. Of course, this column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Column 9 is here. So the number is 0.7235. We write it there. Then plus 3d4 in that column that corresponds to that number. So if we read it, column 4 is this one, which has a 3. So we shall add 3. When we do that, we get the answer being equal to bar 4.7238. So that's how we write numbers in standard form. Remember, if the power of 10 has a negative sign, the negative is written on top of that number, and it's read as bar something, like this bar 1, this bar 4. The characteristic can be positive number, negative, or even 0. The mantissa can never be negative. Thank you.